Hello, Math 20-1. We are starting 3.3, which is a continuation of the journey, the historical journey through solving quadratic equations. And we need to build some skills, and completing the square is a skill that you need to solve tougher or trickier quadratic equations. So building foundation is, how do I make a perfect square? And what does that actually mean? So the first thing is, I want you to expand these binomials and then come back and see what we've got. Okay, so if you've done that, you'll remember that completing a perfect square, I square the first term, I get x squared, I multiply the two together and double it, and then I square the last, and I get x squared plus 2x plus 1. Next one, I get x squared, multiply the two together and double, so plus 4x plus 4. The next one would be x squared plus 6x plus 9. Then I'd have x squared plus 8x plus 16. And lastly, I would have x squared plus 10x plus 25. On these negative ones, I would have x squared minus 2x plus 1, and x squared minus 4x plus 4, and x squared minus 6x plus 9, and x squared minus 8x plus 16, and lastly, x squared minus 10x plus 25. So in general, what do we get when we have x plus a constant? Well, what we get is we square the first term and we get x squared. We multiply x times the constant and double it. So that would be 2 times the constant x, and then we would have plus the constant squared, right? So that's the general rule. Now it's important to notice that that the first term of every one of these binomials is very simple. And that's important because that's how we're going to build these perfect squares. So every one of these has a 1x squared. The other thing that I need you to look at is, what is this pattern of the middle term? So I'm going to underline that in red. Look at the middle term, and based on the middle term, how do you get to the last term of these perfect trinomials? So how does the middle term connect to that? Ponder that and come back. What you should have noticed is that the last term is actually equal to half of the middle number or coefficient squared. And that pattern we're going to need. So if you wonder, okay, well, what's he saying? Well, if you look at all of the red numbers, if you took a half of 10 and squared it, you'd get to 25. A half of 8 is 4. 4 squared is 16. That connection between the middle number and the last number is really important because we're going to use it right here. So how do we build a perfect square from the learnings above? And you're probably wondering, well, why would we want to build a perfect square? Oh, that's coming. But the first thing is, we use the learnings from up here and we say, well, what would this number here have to be in order to be a perfect square? Well, that last number has to be 14 divided by 2 squared. That means it has to be 49. If I factored it, that would be x plus 7 squared. It's a perfect square. What would this number be? Minus 16 divided by 2 squared is obviously 64. That would mean it's x minus 8 squared. This would be 11 squared, which is 121, x plus 11. And you start to get the idea. 20 divided by 2, that would be 10 squared. This number has to be 100. If it is, it's a perfect square and it's x plus 10 squared. And lastly, because of that minus 24, this last number is minus 24 divided by 2 squared. That's negative 12 squared, and that gives me 144, but it's going to be x minus 12 squared. So now we hopefully know how to build a perfect square, okay? We just built them by knowing the middle term and getting the last, okay? We go on, and now, knowing what we know, perfect squares don't always have to be integers. You can build perfect squares from numbers that aren't even numbers, right? So what's the perfect number that goes here? You still do the same thing. I divide by 2. So 3 divided by 2 squared, this number here is 9 over 4. That means that the factor would be x plus 3/2 squared. What's the number here? 1 over 2, right? There's a 1 there. 1 over 2 squared is 1/4. That means it would factor to be x plus 1/2 squared. So these are perfect squares that aren't necessarily integers, right? So square that, I get 49 over 4, which would give me, in factored form, a perfect square of x minus 7 over 2 squared. And lastly, oh my, decimal, you should probably change that to 3/2. So that's minus 3/2. If you were to divide that by 2, so if you divide that by 2, you get minus 3 over 4, and when you square that, you're going to get 9 over 16. Ask me about this one if this one bothers you. When you factor that, you end up with x minus 3 over 4 squared. Okay? So we've hopefully built our skills in perfect squares. Now, why did we learn this again? What's your problem? What are we doing? We're supposed to be solving quadratic equations, right? That's our job. So I've got a quadratic equation here. How many answers should there be for this? Well, based on what we learned about factoring, there should be 2 answers. There should be 2 answers, right? You learned that. Why? Well, because it's degree 2, and degree 2 quadratic equations means there should be, not always, but there should be 2 answers. That's why, right? We learned that. Linear and linear, which was degree 1, that was grade 9. Linear degree 1 only had 1 answer. Now we're big math students. We got 2 now. Now, what's your problem if your life depends on using 3.2 to solve this question? Well, you got a problem, because when you look at x squared minus 12x minus 7, you're supposed to find 2 answers, but you have a sum of negative 12 and you have a product of negative 7, and that should leave you fairly puzzled, because it does not factor. There are no products and sums that give you these, but that doesn't mean there's not answers. There is. You just need to find a method that works, and it happens to be the perfect square method. Okay, so if your life depended, what's your problem? I can't find my answers because my skills, right? Because factoring is not possible, right? Okay. So what are we going to do? We're not going to sit and cry. We end up having to use the square root property. And the square root property can be used when you have perfect, and I know I'm spelling it wrong, but just because, you need perfect squares. So these are perfect squares here. If x squared is 25, don't forget that it's not going to simply be 5. I take the square root of both sides, and I get answers of x equals plus or minus 5. When I take the square root, I take both the positive and negative square root. Okay, same thing goes here. You take the square root of both sides, you are supposed to consider both the positive and negative square root. The square root, boink, blows up the squared, and I'm left with x minus 3 is equal to plus or minus root 13. Take the 3 to the other side, and you get x equals 3 plus or minus root 13. 2 possible answers. This is the exact answer, and you could find the decimals that get approximate equals, but I'll let you do that. Okay, those are the exact answers. So what do I do with this one? Well, the first thing I need to do, I want to use that square root property, but I need to divide by 4 both sides, so I'll get x plus 3 squared equals 6, because I divided both sides by 4. And I now can take the square root of both sides, and I get x plus 3 is equal to plus or minus root 6. Therefore, I take the 3 to the other side and I get x equals minus 3 plus or minus root 6. And all is good, okay? So now, Caitlin and everybody else should know how to use the square root property. But how are we going to use that? You need to follow a procedure, so I want you to copy down the procedure, and then I want us to try and work on it together. So I'm just going to pause, and I'm going to call up the procedure, and you're going to write it down, and then we'll use it. So here's the procedure that I would like you to write down, and then we'll try and make sense of it. So step number 1, if a is not 1, you need to make it 1 by factoring out a, and you'll see what I mean by that. Number 2, move the constraints, and 3 and 4 and 5 and 6 using the square root property. So if you can write those down, we're going to come back in a second and actually use them. So now we're going to put all those steps together. So in the first step, we were supposed to factor out, but we don't. There is a plus 1 here, so we don't need to do that. We are going to take x squared minus 12x. We're going to kick that 7 to the other side, and now we need to make a perfect square. So what number do I need to put there to make it perfect? I need to divide by 2 and square, so this would be plus 36. And if that's plus 36, then this is plus 36. Then I need to factor it. So this is going to be x minus 6 squared is equal to 43. I now can use the square root property like we did before, and I take the square root of both sides, and I end up with x minus 6 is equal to plus or minus square root 43. And all is good because we end up with 6 plus or minus the square root of 43. Those are my two answers. And just so you're clear, x equals 6 plus square root 43 and 6 minus square root 43. Those are my two answers. So we continue on with example 2, and in this example, you have x squared minus 4x. You take that 1 to the other side, and now you need to make this a perfect square. So what number do I add? Well, I end up with plus 4, divide by 2 and square, plus 4. That makes it good. I now factor it, and I've got x minus 2 squared is equal to 5. I now use the square root property, and x minus 2 is equal to plus or minus square root 5, and that means that x equals 2 plus or minus root 5. Those are my two answers. If we go back to the first one, as an approximate value, my numbers are 12.56 or minus 0.56, okay? Now, those are the basic ones where a is equal to 1. We're going to do some where a doesn't equal 1, and they're a little trickier. And now you'll have to use all 6 steps. So in the first one, Mr. Fine's about to take over, so we'll see how it goes. Or Lexus, okay? So in the first one, we'll start off by factoring 4 out of the parts that make it perfect. So 4 factored out of x squared, 4x squared minus 16x is 4x squared minus 4x, bracket, and you've kicked that 7 over. So remember, the part that makes it perfect is this number. Now you know that that number there, negative 4 divided by 2 squared, that number there will be a plus 4, right? But the number that goes on the other side isn't actually 4. It's not. It needs to be 16, because by putting a plus 4 here, it actually is making 16 on that side, right? So you need to be aware of that. So now I factor it like we've always done. 4x minus 2 squared is equal to, in this case, 23. That means now I solve it like we were before. X minus 2 squared is equal to 23 over 4. My square root theorem. I get plus or minus the square root of 23 over 4. And I'm going to continue down here, and x equals 2 plus or minus the square root of 23 over 4. If you look in the back of the book, that's not going to be the answer because you need to do some work. I can't take the square root of 23, but I can take the square root of 4. I get the square root of 23 over 2, and my final answer with the common denominator is 4 plus or minus the square root of 23 over 2. This is the kind of question that you might want to ask me tomorrow, because you might be a little concerned about how to simplify to this, okay? Oh, now we have an example with a negative in it. Yeah, that's what I'm talking about. This is good stuff. So with a negative, a lot of excitement comes into play. So with this negative, we're just going to draw a line so we can see where the fun zone is. So with a negative, we take that -3 out, and we've got x squared. Ooh, x squared minus, ooh, that's a plus 4x, and equals, I kicked that 17 to the other side, so we got that over there. To make a perfect square, as we've been talking about, I need that number, and it's 4 divided by 2 squared, so this is a plus 4. Once again, you'd think you'd add 4 to the other side, but you didn't really add 4 there. You really -12. So what you do to one side, you do the other. I need to put a -12 on that side. So I factor it, because those are the steps. I now factor it. -3 bracket x plus 2 squared is equal to -29. -3 gets divided. I get x plus 2 squared is equal to 29 over 3. And I use my square root property. X plus 2 is equal to plus or minus the square root of 29 over 3. And that means that x equals -2 plus or minus the square root of 29 over 3. And you'll look in the back of the book and you will cry, because it doesn't, ooh, I know, because that's not going to be the answer you see in the back. What you will see is that you need to remember your math 10. What you will see is that you need to remember to rationalize the denominator. I can't take the square root of either of those. And so I will get x equals -2 plus or minus the square root of 3 times 29, 27, 87, all over 3. And I need to have a common denominator, so it'll actually be -6 plus or minus the square root of 87 over 3. This is where we'll probably need to talk a little bit, because that might be a little tricky, okay? But that's the most important part, is this part here. And wasn't that a blast? Yay! Okay. Okay. We'll quickly do this one. And in this one, again, fractions are your best friend. So we need to factor out a -1/3. We've talked about that a few times this semester already. I take out a -1/3. And taking out 1/3 is like multiplying by -3. So this would be x squared plus 3x is equal to -4. I need to complete that square, so I will divide by 2 and square, so this will be plus 9 over 4. What did you do to this side? Well, when you multiply that by a -1/3, what you've actually done, and this gets nasty, is this together makes -3/4, right? Because we multiplied by -1/3, we end up with -3/4, so I got a -3/4 on this side. So I finished this question off, which would be your probably most challenging one, because there's a lot of fractions. And notice that I took the -1/3 out. I have that constant of 9/4 to both sides, and I want you to talk to me about that tomorrow. Why is it -3/4 there, 9/4 there? We then put those two together. We then blow up this 1/3 here by multiplying by -3. Gives us a nice equation where we can use the square root property. And the good part is that the square root of 57 over 4 becomes square root 57 over 2, and you have that common denominator, and your final answer is this, and that is the end. Hey!